Right, welcome. So today we're gonna do about 1 hour past paper practice on chemical equilibrium and rate of reaction. And my next video will be a 1 hour past paper practice session on electrolysis, hopefully solidifying these two concepts for you. And then I want to move on to acid, bases, and salts. So this video and the next video will be on the past paper practice for these specific topics because I believe that helps strengthen your understanding of the concepts. And I will be doing paper 4 because it's my personal opinion from my experience that these help the most with understanding the concepts. Therefore, I will be focusing on paper 4. So let's get started. These are not specific past papers. These are different questions taken from different past papers and compiled together because they belong to the same concept. Okay, let's get started. Hydrogen peroxide decomposes to form water and oxygen. This reaction is catalyzed by manganese oxide. It is catalyzed. It is catalyzed by manganese oxide. So let's remember what a catalyst does. It increases the rate of reaction and it remains chemically unchanged. Right, so we have hydrogen peroxide and it's forming water and oxygen. 40 centimeter cubes of aqueous hydrogen peroxide was put into the flask and 0.1 grams of small lumps of manganese oxide was added. The volume of oxygen collected was measured every 30 seconds. The results were plotted to the graph shown below. How do rates at time T1, T2, and T3 differ? So we had looked into analyzing the graph for rate of reaction in the video that I covered rate of reactions in. And over there we covered that the steeper the slope, the faster the rate of reaction. So let's see. Our slope is the steepest at T1. And as you progress to T2, the slope is decreasing. And when you're at T3, it's completely horizontal. Slope is 0 because slope is rise over run, and over here we do not have any rise. So 0 over anything is equal to 0. So here slope is equal to 0. So how do the rates at T1 and T2 and T3 differ? You need to put down 2 points to gain your 2 marks. So your first point will be that the rate at T2 is less than the rate at T1 because the slope is decreasing. So you will write rate at T2 is less than rate at T1. Here you do not have to give the reasoning why it's how you ended up interpreting that. They did not ask you for your reasoning. They just asked you how do they differ. They differ as T2 is less than T1. And then for your second point, you can say that rate at T3 is 0. And what's actually happening here in this area, for your understanding, it's that the reaction is finished up. The reaction is done. So every time your line goes horizontal, it means that your reaction has finished up. Your reactants are used up completely. Now over here, they asked you to explain the trend in the reaction rate that you described in A. So over here, you do not give your reasoning. Here you just answer the direct question, and over here they have asked you to explain it, and you have to give 2 reasons as well for your 2 points. So 1 reason for each point. Now, why is the rate at T2 less than the rate at T1? So what's happening here technically is they're showing you the progression of a reaction. Now, how exactly does a reaction work? Obviously, your reactant is used up. You were using the reactant. And as you use the reactant, the concentration decreases. And when the concentration decreases, your rate of reaction decreases. So the rate at T2 is less than the rate at T1 because concentration of hydrogen peroxide is decreasing. Now you need to give a reason for why your rate at T3 is 0. The rate at T3 is 0 because hydrogen peroxide is completely used up. The reaction is complete. So at T3, hydrogen peroxide is completely used up. The reaction is complete, or you could say has finished up, or finished, anything along the lines of what I'm trying to say. Now, the experiment was repeated using 0.1 grams of finely powdered manganese oxide. Initially, they were using small lumps of manganese oxide. All the other variables are kept the same. On the axis opposite, sketch the graph that would be expected. Now, I want you to keep in mind that for sketching for your IGCSE exam, always use a pencil. I do have a pencil here, except it's not that great for visibility. So I will be using whatever pen I have over here. However, for your IGCSE, all diagrams and all sketching needs to be done in pencil. So I'll erase this. Now, since you're using finely powdered, that means your surface area is increasing, which means that your rate of reaction increases, because we learned that increase in surface area increases rate of reaction. And if rate of reaction is increasing, that means that you will have a steeper slope. So let's draw that. Starting from the same point and steeper slope. Okay. It's a little hard to do this over here. However, it should be pretty easy for you guys on paper. You guys have to make sure that you have the same volume, because you're still using the same amount of hydrogen peroxide. You're still using 40 centimeter cube of hydrogen peroxide. So it will be used up at the same volume. You still have the same amount of your reactant. So you need to make sure that it ends at the same volume. The only thing that's changing when you have your fine powder is the gradient over here. This is steeper, therefore this is a faster rate of reaction. This is 2 marks, so you guys have to make sure that one, you have a bigger gradient, it's steeper, and the second mark is so that it's on the same final volume. Explain the shape of the graph. Well, it is a steeper graph as rate of reaction increased. due to an increase in surface area. Same final volume as the same amount of hydrogen peroxide is used. Describe how you could show that the catalyst manganese oxide was not used up in the reaction. It did not chemically take part in the reaction. Manganese oxide is insoluble in water. So you've already put in manganese oxide in the reaction. Now after that, they want you to prove that this was not used up in the reaction. So first of all, you are going to filter it. You're going to filter out the manganese oxide that you had placed in hydrogen peroxide. And then you will have to dry it, because remember, this is 4 marks, so you need to give 4 points. So first you filter it, you take it out of the reactant that you had placed it in, then you will dry it because it was obviously wet as it was in a liquid reactant. Then you are going to measure the mass. Now this is for your information, that if the mass is the same, that means that it did not take part in the reaction. So over here you will say that the mass should remain 0.1. or unchanged. So 1 mark, 2nd mark, measure the mass, 3rd mark, and you should say the mass should remain 0.1 grams. That is your 4th mark. So every time that you need to prove that anything did not take part in the reaction, it will be the same amount as it had started out. We started out with 0.1 grams and we were left with 0.1 grams, which means that it did not take part in the reaction. The moles concept we have not done yet, so I will not be doing it. I plan to cover it later after acid, bases, and salt preparation. One of the factors which determine the rate of reaction of solids is particle size. A mixture of finely powdered aluminum and air may explode when ignited. An explosion is a very fast exothermic reaction. This causes a large and sudden increase in temperature. Explain each of the following in terms of collisions between reacting particles. Why is the reaction between finely powdered aluminum and air very fast? Well, basically they want you to explain the collision theory behind the factor that increases the rate of reaction, and here the factor that increases the rate of reaction is surface area. So why is the reaction between finely powdered aluminum and air very fast? It's because it's larger surface area which increases the frequency of collisions, the frequency of successful collisions. Now, again, we have covered this in the explanation video itself, that the higher the rate of collisions, the more frequent, the more often the collisions are, the faster the rate of reaction. So here, what happens is that when you have a larger surface area, this is your large surface area and this is your small surface area. Here, only these two particles will react with whatever is the other reactant that needs to be reacted with. And over here, we have all of these particles that react with, for example, air over here. So the larger the surface area, the higher the frequency of successful collisions, the higher the collision rate. You can say that as well. The higher the collision rate, it's common in the marking scheme, and therefore that increases the rate of reaction. 2 marks. You say larger surface area, 1 mark. Higher collision rate or more successful collisions, collide often. Anything that means the same thing, that's your 2nd mark. Explain why for most reactions the rate of reaction decreases with time. I explained this in the first question, and that's concentration of the reactants decreases. Concentration of reactants decrease. Now, in the marking scheme, they have given the 2 marks for mentioning concentration, and then the 2nd mark for reactants decrease. However, it is very much possible that in a different marking scheme, they give you the 2nd mark for explaining how the concentration, what is the collision theory behind concentration. Now, as a student, you do not know the marking scheme beforehand of whichever exam you're giving. So for the safe side, write the valid point that answers the question. So explain why for most reactions the rate of reaction decreases with time. Concentration of reactants decrease, and which means that the number of particles per unit volume decreases, decreasing the collision rate. Now, in the marking scheme specifically for whichever paper that this question belongs to, they had not told you to specify this point over here. However, it's very much possible that if you, in your exam, get a question along the similar lines in that marking scheme, they do specify that, oh, they should give the reasoning, they should give the collision theory behind the decrease of the concentration of reactants. And as a student, you will never know which marking scheme they are following or what that certain marking scheme says. So you have to make sure that you give the valid points so the examiner is not given any choice to cut your marks. He has no possible way to cut your marks because you have mentioned everything that is valid. Suggest an explanation why the rate of reaction in an explosion could increase rather than decrease with time. So here they said that when they explode, when they're ignited, an explosion causes an increase in temperature, and this is an exothermic reaction, right? So suggest an explanation why the rate of reaction of an explosion could increase. That's because increase in temperature. Now, this is the collision theory behind the factor of increasing temperature. Increase in temperature causes particles to gain kinetic energy. This stands for kinetic energy when I'm answering. However, in your paper, in your real paper, and in your mocks, make sure that you write kinetic energy completely. Causing them to collide more often. And additionally, a greater proportion of particles have sufficient energy for the reaction. This was also explained in the explanation video, how to answer questions regarding temperature and rate of reaction. So what happens when the temperature increases is that particles, they gain kinetic energy, and when they gain kinetic energy, they end up colliding more often. there is a higher collision rate, which increases the rate of reaction. And also you have a greater proportion. So if you see this as a simple example really quickly. Now over here, you only have these particles reacting. However, and that makes 1, 2, 3, 4. However, if you increase the rate of reaction this much, which is 6, have sufficient energy for the reaction. A greater proportion of particles has sufficient energy for the reaction, which increases the rate of reaction. So those are your 3 points. Increase in temperature, 1 point. Kinetic energy, gain kinetic energy, collide more often, 2nd point. And 3rd point is a greater proportion of particles have sufficient energy for the reaction. Give another example of a substance other than metal, which when finely powdered might explode when ignited. And there are many different things. Anything that, well, for example, wood, powdered wood, wood shavings, wood dust. Now this is common knowledge, I guess you could say, that the IGCSE chemistry papers tend to test sometimes, although mostly they focus on exactly the points that you've covered in your textbooks. However, you know that there is air and there is igniting happening, so wood dust would very much cause an explosion. Flour as well, coal dust, carbon. Now these are the type of answers or the type of knowledge that you will get by constantly solving past papers. These little 1 mark, these points that you will not see in your textbook or in notes here and there because they're not exactly as important. So this you will just get from maximum past paper practice. Describe a simple test tube reaction which shows the effect of particle size on the rate of reaction at which a solid reacts with a solution. I have done a video on the experiments regarding the reaction rate. So if you have a good knowledge of that, you can easily come up with something over here. So first, you're obviously going to need a solid. You need something, you need a reactant, and you need it to have a particle size. So let's use magnesium. Use 2 test tubes, okay? Place lumps of magnesium in one, and place finely powdered magnesium in the other. Add an acid, let's say hydrogen sulfate, and observe that the rate of reaction is faster in the finely powdered tube. Right, so how will you think for an experiment? We were going to need reactants, and I chose magnesium, and I chose hydrogen sulfate or hydrosulfic acid. Now you know that you need to test the particle size, which means that you need to compare when it's finely powdered and when it's a lump size. So you need 2 test tubes, and you will place lumps in one and you will place finely powdered in the other. And then you will add the acid and you will observe The rate of reaction is faster in the finely powdered tube. Now this is 3 marks, so you presented 3 points. 2 test tubes, place lumps and finely powdered in one, add the acid. That would come in with your second point. And observe that the rate of reaction is faster in the finely powdered rate. That's your conclusion. Now, it's a 3-mark question, so if you had, it depends on the marking scheme. However, if I had omitted add an acid and yet had the 3 points other than that, it still would have counted. However, I have told you guys that you write the complete logical answer for your questions. Do not give your examiner any chance to cut your marks. Give 3 to 4 solid points for when you have a 3-mark question, okay? So in case your any third point that you had initially written is wrong, your 4th point is coming in as backup. If this was a 4 to 6 mark question, you could say, instead of simply ending it on observe that the rate of reaction is faster, you could say observe the rate of bubbles formed are faster in the finely powdered tube. And you could also give more details on how you have to have the same concentration of hydrosulfuric acid for both tubes, and you have to have the same amount of magnesium, same mass of magnesium for both test tubes. Those are extra details that you would add for any question that would require, that is worth a greater number of marks, okay? Now, the speed of a chemical reaction depends on a number of factors, which include temperature and the presence of a catalyst. Explain why reaction speed increases with temperature. I have explained this before, that it's always going to come for 3 marks. And those 3 marks should be embedded in your head, and we covered it in a question before. So particles gain kinetic energy. That is 1 mark. That increases the collision rate. That is your 2nd mark. And your 3rd mark will be a greater proportion of particles has sufficient energy for the reaction. This you can have memorized. Why does the rate of reaction increase when temperature increases? Particles gain kinetic energy, causes them to collide more often, increases the collision rate, and a greater proportion of particles has sufficient energy for the reactions. Do make sure to mention that when you say particles gain kinetic energy, they move faster. Make this 1 point altogether. Particles gain kinetic energy, which causes them to move faster, increasing the collision rate, and a greater proportion of particles has sufficient energy for the reaction. Enzymes do not follow the above pattern. The following graph shows how the speed of such reactions varies with temperature. Suggest an explanation why initially the reaction speed increases, then above a certain temperature the speed decreases. So what happens is that as the temperature is increasing, the following graph shows the speed of the reaction varies with temperature. So we already know that temperature is increasing as we go here. So initially, as temperature increases, the rate of reaction increases. However, if you remember, I told you that they have a very specific working temperature. So after a certain temperature, the enzymes, after a certain temperature over here, the enzymes are denatured. They are destroyed. So after a certain temperature, They are denatured. So initially, as temperature increases, the rate of reaction increases. After a certain temperature, they are denatured. So your first mark is to say that reaction is faster when temperature increases. And your second mark is for mentioning that they are denatured. Right. An organic compound decomposes to give off nitrogen. The speed of this reaction can be determined by measuring the volume of nitrogen formed at regular intervals. Typical results are shown in the graph below. The reaction is catalyzed by copper. Sketch the graph for the catalyzed reaction on the diagram above. So in the first part, what they're doing is that they're catalyzing the reaction. And when you catalyze the reaction rate increases, which means that you have a steeper gradient. You're still using the same amount of the reactant, so you will have the same volume. Again, your sketching will be easier when you're doing it on paper. There we go. How does the speed of reaction vary with time? The speed of the reaction, it decreases. As you can see that overall, you can see over here, this is a decreasing gradient. This is a decreasing gradient, and this is an increasing gradient, just for information for anyone who did not know. Why does the speed of reaction vary with time? Well, the concentration, again, very similar. As you guys can see, these are the exact same questions as the first question that we attempted. The only thing is that they changed the reactant name. The working is still the exact same. The thinking process is the exact same. So the concentration of the organic compound is decreasing. Which decreases the collision rate. Usually the why questions, and you can put this as a note in your head, the why questions with reaction rate basically mean that you have to explain the collision theory. And how are you going to explain the collision theory? We went over this in the reaction rate video, is that you will say the factor that is affecting the reaction, and then you will explain the explanation, which is the collision theory for that factor. How is that factor affecting the reaction rate the way that we have said? That is the collision rate. So all your why questions, you will say the factor and then you will explain the collision rate. We did cover catalytic converters, describe how carbon monoxide and oxide of nitrogen are formed in car engines. This is very important. This question is practically repeated in almost the same words. So carbon monoxide, all monoxides are incomplete combustion. Okay, so carbon monoxide is incomplete combustion of the carbon-containing fuels. The oxides of nitrogen are formed due to the reaction, are formed because nitrogen and oxygen react at high temperatures. Describe how carbon monoxide and oxides of nitrogen are formed in car engines. So, like I said, carbon monoxide, the term monoxide, monoxide, you will immediately know that it is incomplete combustion of carbon. That is simply how monoxide is formed. And it's incomplete combustion of carbon-containing fuels. Oxides of nitrogen are formed because nitrogen and oxygen, they react at high temperatures, and because the engine, it has a high temperature and they react in the engine, so due to that they end up reacting and forming the oxides of nitrogen. Over here, because it is easier for me to remember that carbon monoxide is formed by the incomplete combustion of carbon containing fuels. However, you can use words like petrol or fossil fuel if that is easy for you to remember by definition. However, I think it's easier to remember that incomplete combustion of carbon-containing fuels forms carbon monoxide. Describe reactions inside the catalytic converter which changes these pollutants into less harmful gases. Include at least one equation in your description. So you do not need to write a chemical equation for all the reactions. So oxides of nitrogen, they turn to nitrogen itself. Remember, I told you guys that nitrogen makes up 78% of the air, so it's not as harmful, or it's not harmful as oxides of nitrogen are, because they play a factor in forming acid rain. Now, I believe to the chemical equation for carbon monoxide to carbon dioxide is easy, so I will write the chemical equation for that. So carbon monoxide plus oxygen will give carbon dioxide. Now, you need to make sure in your chemistry exam, every time they ask you to write a chemical equation, even if they do not mention this for you, you have to do a balanced equation. Your marks are always given in the sense that 1 mark will be for your equation to be balanced. Over here, we have 3 oxygens and 1 carbon. Over here, although this is quite easy to do mentally, I will do it properly for you guys to understand. Carbon is 1, oxygen is 3, carbon is 1, oxygen is 2. So if I put 3 here to balance it out, I get 3 and I get 6. Wait, no, I'm sorry. 1. And, right, sorry, okay. So, we have 3 here, we have 2 here. If I put 2 here, I get 2 and I get 4. If I put 2 here, I get 2 here, and I get 2. Plus 2, I get 4. When you see that everything on this side of the table, on the left side of the table, is equal to everything on the product side of the table, the right side of the table, that means that your equation is balanced. And for any reason, if they did not know how to write the carbon monoxide to carbon dioxide equation, which is pretty basic information, you guys should have it on your tips, on the tips of your fingers. You could just write carbon monoxide and you write your product, and you will see that what is added to it, oxygen was added to it. And this is how you write oxygen. And then you will balance it. So your first mark is for this reaction, the oxide of nitrogens are turned to nitrogen. Your second mark is for the carbon monoxide, oxygen makes carbon dioxide. That's your second mark. And your third mark is for this balancing right here. This is a lot of organic chemistry, which I do not want you to get into. These are acid, bases, and salts reactions. And over here, okay. Explain why the temperature increases rapidly at first. I believe since the entire question is related, I will not attempt it because it starts off with something that we haven't covered yet. So let's move on to the rest of the questions. This you will find a lot while practicing by topic for chemistry. Obviously, the past paper questions, they cannot completely remove all parts that you still haven't done. So you just have to know that, okay, this is not part of what I have covered so far. Therefore, I will not attempt this question. All right. Iodine reacts with chlorine to form dark brown iodine monochloride. This reacts with more chlorine to give yellow iodine trichloride. An equilibrium forms between these iodine chlorides. What do you understand by the term equilibrium? This is a very, 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 very common question. It'll always come for 2 marks. Therefore, you should have the definition embedded in your head. What is meant by the term equilibrium, and this I covered in the chemical equilibrium video itself, is that the rate of forward reaction is equal to rate of backward reaction in your exam. It would be safer to write equal to, I'm just writing the sign so we can move faster. Rate of forward reaction is equal to rate of backward reaction, and your second point will be the concentrations do not change. Concentration of reactants and products. Reactants and products do not change. Every time they ask you for the definition of equilibrium, it is the rates are equal and the concentration does not change. When the equilibrium mixture is heated, it becomes a darker brown color, suggestive the reverse reaction is endothermic or exothermic. Right, so when the equilibrium mixture is heated, it becomes dark brown. So when you raise the temperature, the equilibrium shifts to the left. When you raise the temperature, the endothermic reaction is favored. Every time you raise the temperature, endothermic reaction is favored. So that means that the reverse reaction is exothermic. So first you will suggest if it's endothermic or exothermic. So you will write that it is exothermic. And then you will give your reasoning. Okay, 1 second. Apparently, or this is a bit of a trick question over here. When they ask, they said that when the equilibrium mixture is heated, it becomes a dark brown color. And we established that that means that the equilibrium is shifting to the left. And since it is heated, it's an endothermic reaction. Now, when they suggested the reverse reaction is endothermic or exothermic, I thought they meant the reaction that is opposite to whichever reaction is being favored right now. However, what they mean when they say reverse, they mean the reaction that has the arrow shifting leftwards, which is this right here. So they're asking us to suggest if this reaction, the one going from the yellow to the dark brown, is endothermic or exothermic. And that we already established with the reasoning for the heated temperature and the color becoming browner, is that it is endothermic as rise in temperature is favoring reverse reaction. So that will give you your complete 1 mark because they asked you to suggest and give the reason. So it is endothermic, and the reverse reaction, the reaction going this side, is endothermic because the rise in temperature is favoring that side. Because an increase in temperature increases endothermic reaction. And here the heated one is going and making the brown color. The pressure in the equilibrium mixture is decreased. How would this affect the position of equilibrium? Right. Let's count our moles. 1, 1, and 1. So in our reactants, we'll have a total of 2. 1 plus 1, 2. In our products, we have 1. Now, we had established in the video where I explained chemical equilibrium that an increase in pressure favors the side with the smaller number of moles, which means that if the pressure was increasing, it will go to the product side. However, here they are decreasing the temperature, so it would move to the left. It would move to the reactant side. And the reason for that would be is there is more moles on left-hand side. More moles on left-hand side. Write the full form in your exams, okay, guys? So once again, increase in pressure favors the side with less amount of moles. However, over here, they're decreasing the pressure, which means that more moles will be favored. And more moles are on the reactant side. Describe what you would observe. Well, if our equilibrium is shifting to the left, once again, then that means it's going to be moving this side, which means that it's going to become dark brown. So you could say more dark brown liquid. Okay. This is the chemical energetics video that I have also done. Calculate the overall energy change for the reaction between iodine and chlorine using the bond energy values shown. Show your working. So, we have I to I given. All right, so we're going to do the reactants first. We have I, and we have that given 151, and we have chlorine. We have that as 242. That gives us 393. Then we'll do the product side, which is INCl, and you can see that there's a coefficient of 2. So you're going to do 2 into 208, which is given in the table. That is 416. And they want the overall energy change, which means that they want the delta H. Remember, delta H is whatever energy you get for the reactants minus the products. It's always reactants minus products. So 393 minus 416, you get minus 23. Now, just for your information, in your marking scheme, they have specified that the sign must be written. So it is important because this is what determines if your delta H is negative or if it's positive. That's what determines if your reaction is exothermic or endothermic. Draw a labeled energy level diagram for the reaction between iodine and chlorine using the information in D. The information in D tells us that it is an exothermic reaction because it's a negative delta H. And we have covered what the energy profile diagrams for exothermic and endothermic reactions. So your energy profile diagram would look something like this. So energy over here and time maybe, sure, and this will be your reactants, this is your activation energy, and okay, this thingy is supposed to look a little like a mountain peak. I mean, they're not gonna look for such artistic details, but there we go. So they said labeled diagram, so you know that we have I2 and Cl2. Okay, I2 plus Cl2 here, and then 2ICl here. Then over here we have the activation energy, and then from here to here we have delta H. So that is your energy profile diagram. Now it's 2 marks, so first of all, drawing the exothermic reaction itself, and then labeling anything, the reactants, the products, the activation energy, axes, any of that, any 2 of all of this will get you your 2 marks. However, once again, do not give your examiner the chance to cut marks. Always have your backup answers available. Explain the term of equilibrium. This question, I've told you, it comes way too many times, so I will not write it again. However, you guys know that it's the rate of reaction. It's the equal rates, and actually, you know what? I could just copy this. It's the equal rates and the same concentrations. Can I copy this? No. Okay, something like that. There we go. The following graphs show now how the percentage of products of a reversible reaction at equilibrium could vary with pressure. For each graph, decide whether the percentage of products decreases, increases, or stays the same when the pressure is increased. Then match each graph to one of the above reactions and give the reason for your choice. These are the reactions given to us. So what is the effect of percentage of products? You can clearly tell that as your 2, 4, 6. You can just tell, however, for anyone who's having trouble, I will explain it here. You can see that when it's 2, it's somewhere around, around 1, for example. When it's 4, it's becoming somewhere around 3. When it's 6, it's becoming 4. So as the pressure is increasing, your percentage of product is increasing. That means that when the pressure is increased, your product is increasing, which would mean that the product has a smaller number of moles, because an increase in pressure causes equilibrium to shift to the side with the smaller number of moles. And if your product percentage is increasing, your product yield is increasing, that means your product side has a smaller number of moles. Which reaction would that be? Here we have 2 and 2, reactant side mole, product side mole. Here we have 4, 2, and here we have 2 and 3. So reaction 2 is the one that has a smaller number of moles on the product side. Now over here, your percentage of product is the same. It remains constant even though your pressure is increasing. That means that the increase in pressure is not having any effect. It's not altering the position of the equilibrium. And that would happen when you have the same number of moles, because where would it shift to? If you increase the pressure, it shifts to the smaller number of moles side. However, if they have the same, then it cannot shift to any smaller number, as the smaller number doesn't exist. And that is reaction 1. It remains constant. All horizontal lines and graphs means constant. Reaction 1. And the reason is that same number of moles on reactant and product side. You could also write same over here. Now the effect on the percentage, it's, as you can see, that as this increases, 10, 9, 8, just random values so you guys can learn how to view the graph in your head. This is usually easy for most people, however, for anyone who is unable to understand. As you can see that when it was 1, the product percentage was 10. And as your pressure increased to 4, your product percentage became 8. It decreased. So it is decreasing. Which means that, okay, first of all, process of elimination, reaction 1's gone, reaction 2 is gone. It's obviously going to be reaction 3. However, you can also see that its reactant side has 2 and the product side has 3, which means the equilibrium is going to shift to the reactant side, decreasing your product yield. Again, same, this is the same question. Okay. This is your metals concept, which we haven't covered yet, so I will move on to part B. At 25 degrees Celsius, the mixture contains 20% nitrogen dioxide. At 100 degrees, this has risen to 90%. Is this forward reaction exothermic or endothermic? All right, so when you increased the temperature, the product yield, not the product yield, okay. The reactant side is what increased. Your nitrogen dioxide is what ended up increasing. So that means that an increase in temperature is causing the equilibrium to shift to the left, which means that your forward reaction is exothermic because an increase in temperature favors the endothermic reaction, which is your backward reaction. Therefore, your forward reaction is exothermic. And how is it exothermic? Always just, your straightforward reason is that it is favored by lower temperatures. Obviously, if your backward reaction is endothermic, it is favored by high temperatures, which means that your forward reaction will be exothermic, which is favored by lower temperature. So 2 marks for saying exothermic, second mark for saying that it's favored by lower temperature. Explain why the color of equilibrium becomes lighter when the pressure on the mixture is increased. So again, with pressure, you're going to calculate your moles. There's 2 on the reactant side, 1 on the product side. And what is happening? We are increasing the pressure, which means that our equilibrium will shift to the right. So equilibrium shifts to right hand side due to lower moles or smaller moles, causing the color to become lighter. Right. So again, you're increasing the pressure. It favors the moles with the lower side. The lower side is the pale yellow side, and so your color is decreasing. Moles concept we have not done yet. And although, no, this has a lot of okay, we're just gonna do the first 2 parts, and first 3 parts, and we're gonna call it a day. Right, so when the pressure on the equilibrium mixture is decreased, the position of equilibrium moves to the left. Right, how does the concentration of each of the 3 chemicals change? Well, if you're moving to the left, if you're moving this side, then the concentration of the reactants will increase, which is CO and Cl2. Their concentrations will increase. Wherever equilibrium is shifting to, that side's concentration will increase always. And the product will decrease. Okay, its concentration would decrease. All right. Is moved to the left because a decrease in pressure favors side with more moles. Use the information given with the equation. Is a forward reaction exothermic or endothermic? Give a reason for your choice. Use the information given within the equation they have given us. Okay. So when you're moving forward, just focus on here. When you are moving forward, you are cooling, which you guys should know by now that a decrease in temperature is exothermic, favored by lower temps or temperatures, technically. Write temperatures in your exam, please. Alright, so that's all the past paper practice we are to do for today. For the topics that we have recently covered, in our next session, I'm going to do past paper practice on electrolysis, which I hope will be helpful for most of you, and then we will start acid, bases, and salts. I hope this was helpful, and if there is any specific topic that you want me to cover up quickly and do its past paper practice session, and more than just one past paper practice session for that topic, then comment it down below and I'll try to get it done as soon as possible.